What? You lost the bearings? Did you remember to start from the north? Hold on. Let me get this lesson started so I can get you some help. Welcome back to Brilliant by Numbers. Today, we're going to be taking a look at bearings. And you may ask, why bearings? But bearings play a very important role in careers and industries. From the making of aircrafts, landing gears, satellite systems, navigating land and sea, and also directions on maps and globes. In this lesson, I'm going to be breaking down the concept of bearings, from measuring to drawing to calculating while integrating the trigonometric ratios. So now let me invite you to explore this beautiful topic with me. Now, before we get started into the meat of this matter, ensure you have the following equipment. In order for us to draw bearings, we need to ensure always we are prepared. So, what do you need? First of all, you need a ruler marked in centimeters and millimeters. Secondly, you need to make sure you have your protractor. And thirdly, you need a sharp pencil. Now, why do you need a sharp pencil? Now, whenever we are marking angular questions, you are only allowed to be 1 degree above or below the actual answer. So, for example, if an answer was 50 degrees, if you have 49 degrees or you have 51 degrees, you would still score that mark. Now, a sharp pencil ensures accuracy because you will now be drawing a very thin line. And of course, on your protractor, you can see that the tiny 1 degrees is really, very small. So a sharp pencil is best to use to do that. Now that you should have paused your video, go along for your equipment, you should now be ready. So, what is meant by the term bearing? Now, in mathematics, when we talk about bearings, it is defined as an angle measured clockwise from the north. And I've highlighted those keywords here so that you focus on them. So it's an angle measured clockwise from the north. And we all know how our clock operates and the direction the hands of the clock will go. Now, let's look at some key facts about bearings. Now, if you're going to be good at this, these facts are things you must know. So, fact number 1, we've discussed already, that bearings are a measurement of angles, but they are taken from the north. Very important there. Second point, bearings are always measured clockwise. Thirdly, we use 3 figures to represent bearings. And I've cited some example here. Now, for example, you have a bearing of 3 degrees. You cannot just write down 3 degrees. You have to say 0, 0, 3. 46 degrees, you have to say 0, 4, 6 degrees. And of course, 3 figures are already 3 figures, so nothing to do there. Finally, always start with the point that comes after the word from. So, you're asked to draw a bearing. If the point does not come after the word from, that's not your starting point. Okay, and we'll put that a little bit more in context as soon as we get into some questions. So make sure that you write down these 4 points and then we're ready to go along. Now, to the point of cardinal points. Now, because we are talking about angles, we always have to have the cardinal points in the forefront of our minds. Because when we're asked, for example, to sketch bearings, it is the concept of these cardinal points that will help us to make a fair sketch of what we're asked to do. So here, we start at 0, but notice we haven't just put 0 because bearings use three figures. So we say 0, 0, 0. Now, if I go all the way around, and we've done angles around a point, we also know that the angles within a circle add to 360 degrees. So therefore, if we complete one revolution, we have completed 360 degrees. But on our way, there will be smaller degrees, of course. So I'm just going to make reference to the main ones, because usually when we're asked to sketch a bearing, we focus on the main ones, which are east, south, west, and also the north, which is our reference point. So we know that east is 090. We know that south is 180 degrees, and we know west is 270 degrees. So because we know those main ones, clearly we can make estimates of where, for example, 45 will fall, where will 30 degrees fall, and so on. And of course, this is a beautiful opportunity as a math student for you to see where this fits in other subjects as well. The geographers will know that geography relies heavily on your bearing skills as well. Now, it's time for us to learn how to measure angles. Now, if we're asked to draw a bearing, we will have to ensure we know how to manipulate our protractor. So what I would suggest here, you do not have access to the questions on the screen, but you can draw an acute angle. And you can work along with me just to make sure you know how to place your protractor properly when measuring an angle, because measuring angles are very integral to navigating bearings particularly accurately. So I have on screen here, I'm asked to measure the bearing of B from A. Now remember, we said that when we are going to make our reference point, it is always the one that comes after the word from. So I'm going to have to put my protractor at A. Now the center of my protractor has to go on A, and I have to ensure that the baseline of the protractor is flat, set on the north line, and I'm going to demonstrate that now. So nice and calm, I'm going to slowly put my protractor in. You notice here that my center is on A. My baseline is on the north line, and I have to pay attention to my scale. My protractor has two scales, an inner scale and an outer scale. Now I use the scale that is flat dead onto the north line on 0. So if I look here, it is the outer scale that's on 0. So from 0, I need to count off and measure this angle. So my marking is here along. Very good practice to use your pencil, that sharp pencil, and make that little note there. And so that angle is approximately 58 degrees. However, I cannot write 58 degrees down. Why? I hope you remembered bearings has to be 3 digits. And so then to represent that bearing, I have to write 058 degrees. Fantastic. Okay, now also when I'm going to be measuring, a good practice as well is to use my knowledge of the cardinal points to kind of give an estimate to myself as to how large is this angle seemingly. I can see here, if I go to the east, that's 90 degrees. And if I go to the south, that's 180 degrees. So clearly, this particular angle is between 90 degrees and 180 degrees. I give myself a focus there. So I get my protractor, I put the center on my reference point, ensure that my baseline of my protractor is on the north line. I pay attention to my inner scale or my outer scale. Again, I am using my outer scale because that's the one that's on 0. So here I can see dead on here, this is where my angle is. Put a little mark there, and that's 150 degrees. Already 3 digits, so therefore I can just write that bearing down. Now, for the third example, a very, very important question here. Now, if you notice, this time we are finding an angle that is greater than 180 degrees. We are finding a reflex angle, considering the fact that we have to come all the way from the north in a clockwise position. We're going all the way around to B. Unless you have a circular protractor that's already marked out in 360 degrees, you are not able to use the half protractor to do this. So here is what we have to do. We have to measure the acute angle and then subtract that from 360 degrees, and then the answer that's left would be the bearing we are asked to find. Brilliant. So this time I have to turn my protractor the other way. So here we go. So I put my protractor here, and now I notice that the scale I need to use is the inner scale, because the inner scale is the one that's on 0. So I mark that small angle off, and that's 64 degrees. But I was not asked to find that angle. I'm only going to be using that angle to help me to find the one I was asked to find. So therefore, I have to subtract 64 from 360 degrees. I've already pre-done that here. So then the reflex angle is 296 degrees. And so all you have to now do is to just highlight this bit around, and then you put your 296 there. And that's the angle. You can then erase the 64 altogether so that your examiner doesn't get confused about your working. Okay, beautiful concept there, just to remind you of how to measure your angles accurately. Now, with that being said and done, and with the cardinal points being reviewed, we are now ready to do a rough sketch. Now, notice the word here is rough sketch. This means that I do not use my equipment for this. I am only going to use my concept of my cardinal points here to do an estimate. Now, if you get a worded problem in your examination, this is what we expect you to do. Just make a rough sketch. You do not need to draw this accurately. So here, we're asked to draw a rough sketch to illustrate each of the following bearings. Example 1, the bearing of a point T from a point M is 082 degrees. Now, key point here, remember our reference point is always the one that comes after the word from. So I go and I underline from a point M, which means my starting point is M. So I go here and I make a reference point, I call that M. And I'm going to now put my north line. You always make your north line because your bearings is measured from the north. Now I'm drawing 82 degrees, and I know that my cardinal point to the east is 90 degrees. Therefore, I'm expecting 82 to be somewhere along here. Remember, it's just a sketch. We don't expect you to be dead on accurate. However, we can see that you've used your cardinal points as your reference. So I go ahead and I write 082 degrees. But remember, we were going to the point T. So I'm going to label my end point T, and also it's a good practice to end with a north line. Why? Because questions could ask you to carry on to draw another bearing from T. So once you've put your north line, your reference point from T, you would have been ready to take on any other part a question may ask you to do. Brilliant. Not as bad as you thought they were. Okay, so example number 2. We're asked here to the bearing of a point D from a point G is 194 degrees. What reference point do you think is best to use here? I hope you said 180 degrees. So I'm going to focus on from, and I'm coming from a point G. So I go and I start with the point G. I make my north line here, which is my reference point. Now I'm thinking cardinals. I know 180 degrees is to the south, so therefore if I imagine in my mind 180 degrees is somewhere along, straight along. So 194 is going to be somewhere approximately here, and then I label that D, make my north line, but then I'm going to show that all the way around here is 194 degrees. We've gotten through 2 examples, and I hope you notice here the first one was an acute angle and the second one was an obtuse angle greater than 180 degrees. Now the next one we have here, we're asked the bearing of a point K from a point F is 304 degrees, and we're asked to do that as well. So from, we highlight from, and it's from the point F. So therefore I start with my point F and I put my north line in. So now I know if I go to the west, that's 270 degrees. And I know that dead on north, that's going to be 360 degrees. So 304 is going to be somewhere along here. So I'm just going to put my north line here, and then I'm going to write K. So I need the distance all the way around to be 304 degrees. So let's do a check. I've drawn 82 degrees. So that's an acute angle. I know my obtuse angle is going to be greater than 90, less than 180. So this one is also a reflex, and that one is also a reflex. Just make a quick correction there. Okay, so we've completed those 3. Beautiful, not bad at all. All right, so we carry on. Now we're going to go now into drawing some bearings. Now here, example 1, B is a bearing 120 degrees from A and a distance of 4 centimeters. Now you can see the context of the question have changed, because now our distance has to also be accurate. So in the ones we did before in the sketch, we just wanted to find what the angle is, but now we have a specific distance as well. Now this is where both protractor and ruler comes into place, and of course our sharp pencil. So again, we go back through the question. We're told B is a bearing 120 from A. So my reference point, starting point, is the point A. So I go ahead and I put my point A in and my north line. I know my direction is clockwise, so I get my protractor. I put the center of my protractor at the point A, baseline on the north line, and observe my scale. I am using the outer scale. I go ahead and I mark 120 degrees off. However, because I was asked specifically to do a distance of 4 centimeters, I now need my ruler to measure that 4. So I mark my 4 off and I put my point B there. Now, a good practice here would be just to simply erase the extended part of the line. Okay, so you can do that, or just make sure you put your 4 centimeters exactly between A and B, and just like that, you have drawn a bearing 120 degrees from A, distance 4. I know you didn't know it was that simple. It is that simple. Okay, so for the next question, we are asked to do, we're told that B is a bearing 225 degrees from A, again from A, distance this time is 5 centimeters. So we go ahead, we establish our point A, establish our north line, we're going clockwise. I hope you noticed that this time we are drawing 225 degrees. And like I said before, unless you have a circular protractor, you would not be able to do that. So what we would need to do here is to draw the subtract 225 from 360 and then draw the smaller angle. Okay, so I'm going to measure the smaller angle, which is 135 degrees. So here you could have just written, let your examiner know what you're doing. Do 360 take away 225 degrees, and therefore I'm going to draw 135 degrees just to make sure of clarity as to where that 135 came from. So now I have to put my protractor. You can see the progression here, because when we were just learning how to measure angles, we had to do this as well at the beginning, and that was nicely structured there just to build up that momentum so you could make the connection when we get here. So remember now, I was not asked to draw 135 degrees. Rather, I have to use this one to establish the one I was asked to do. So then I know the angle around from the north would be the angle that's in focus here. However, let's pay attention first of all to the 5 centimeters. So I get my ruler, I measure 5 centimeters off, I put that on my diagram, and then I will put my 225 in. And for the purpose of this question, I have simply removed the one I had to use to help me to get my answer. So you can just erase that off the diagram. Your examiner looks on and see dead on what you've done. Now, also make sure you put your working out. Brilliant. And as I said, brilliant. You are becoming brilliant by numbers. I hope you see what I did there. Okay, now we're going to move on. So we've drawn some bearings, we've measured some angles. Of course, you know by now I'm excited about my subject, so I'm in my zone, and I hope that I managed to send that positive energy across the airwaves as well. So now we are going to calculate some bearings. Now, John runs from A to B and back again. Question part A asks us, what is the bearing of his outward run from A to B? So, reference here from A. We go to the reference point here. We're told to do A to B. So I make a connection from A to B. It means then that there's no calculation here to do. The angle is already there. So another context in which the exam could put this, it could say write down. Now write down is a message in itself. It means that your answer is right before you. Find it, write it down. Work out means you have to go to the mathematics gym and you have to do some more work. Okay, so for this question, part A, we simply just need to write 0.57 degrees. So this is just a test to see, does the student remember bearings use 3 digits? Okay, so we've done part A. Now let's focus on part B. Part B says, what is the bearing of this return run from B back to A? So my reference point here is the north line at B. I'm going to go around and make a connection all the way back here. So that's the angle that we're asked to find from B all the way to A. Now here is an opportunity for application. You have done angles in parallel lines. We talked about corresponding angles, we talked about alternate angles and so forth. So you have to see when you can take opportunities. Now here I recognize that the angle here is a corresponding angle to 57 degrees. So that angle is also 57 degrees. Now if you look here at the bottom, this bit here is a straight line, which means that this angle here is 180 degrees. So to get from the north all the way around back to A, I simply need to do 57 degrees plus 180 degrees. Now, is there another way you could have done this? Sure, you could have. We talk about that just as soon as we've added these two together. So I've got 57 and I'm adding that to 180 degrees. And the answer is 237. So I'll just put part B here. Now, good thing to do here also is to give reasons as to what you're doing. So I've put here corresponding angles are equal. You write that on your paper. Show your examiner your thought processes. And so then the angle here, as I said, is 180 degrees. So I'm just going to do 57 degrees. I'm going to put 057 plus 180 degrees. My total answer here is 237 degrees. Already 3 figures, so nothing here to do. Brilliant. We could also have taken, because I like to show different routes because we're doing bearings. And of course, we know sometimes we make an error in our driving calculation, but guess what? Google Maps will reroute us. And so mathematics has different routes we could take, but we will still get to the same destination. So you could have also done this interior angle here. So these two angles, 57, I'm going to call this one X, also add to 180 degrees. So I could have also subtracted 57 from 180 degrees and then take that angle away from 360 as well. Because I know some people would have seen this and that's okay to do. Okay, so now we have done a calculation. Time to move on to some more exam style questions. Here I am given this beautiful diagram here. Now you can see I now have not 1, not 2, but 3 points. We apply principles. We are not intimidated at all by the complex look of a question because we have the skills. We just need to execute. So let's go. We're given this diagram. We're told specifically here it is not drawn to scale. And that's because we want you to know you cannot use a protractor to measure to get the angle here. So we're asked to work out context. The bearing of C from A. Reference point is C. So I'm going to C. My reference point is A. So from A, so let's do that from A all the way around to C. We can see here that we just need to add those two angles together. So for the answer, it will be 130 degrees add 80 degrees. Let's put that in our calculator. So 180 degrees, sorry, it was 130 plus 80. Okay, and that is 210 degrees. 3 figures, nothing left to do. All right, so we're going to go on to do another example here. This one is worth 2 marks. The first one was just worth 1 mark. Not much that we had to do there. So the 3-figure bearing of B from A is 021 degrees. Work out the 3-figure bearing of C. So this question is a very kind question because it reminded you, I hope you noticed, it reminded you, it said 3-figure. So even if you forgot, this question was a very kind one. So work out the 3-figure bearing of C from A. So I go to my reference point, I'm going from A. So from A to C, and they have already told us that this was 21 degrees, 021. So therefore, I just need to add these together. So the answer is 21 degrees plus 58 degrees. And we just put that in our calculator. So 58 plus 21 gives us 79 degrees. Remember, we cannot just write 79. We have to say 079 degrees. Easy to marker there. Brilliant. Now, before we get into our next example, just want to take the opportunity to remind you that we are also on TikTok. Feel free to hop over there and engage with that content as well, so you get that additional practice on your exam style questions. With that being said, let's carry on to our next example. So in this example, we're told that J and K are ships. P is a port. J is due south of P. Angle JPK is equal to 56 degrees and JP is equal to KP, and this diagram is not drawn accurately. We're asked to work out the bearing of J from K, and this one is 3 marks. So we are going to focus on the fact that we have an isosceles triangle here. And the question itself told us that because it said that JP is equal to KP. We know that the angles at the base of an isosceles triangle will be equal, so we can find out what is the size of one of those angles there. So I'm going to do 180, take away the 56 in the triangle, and if I divide that by 2, that will get me one of the angles in the triangle. So we're going to do 180, take away 56, and then divide that answer by 2, and we get 62 degrees. So we're going to put that 62 degrees on our diagram. So 62 degrees. Now that's a part of closing the gaps in this question. But remember, we are going from K. So this is all around from K to J. That's the angle that we need. So we've got a part of it here. Now we can reason that this is a line here which is parallel to this one. So that means this angle here will also be 56 because it is alternate to the 56 in the triangle. So therefore, to get my answer, I will just need to do 360 degrees, and that's because all of the angles around a point add to 360 degrees. So if I subtract the sum of 56 plus 62, that will get me the angle just from the north line all the way around to J. So let's just put that in our calculator. So 360 degrees, take away 56, and also taking away 62, and then we get 242 degrees. So there we have it. We have access also a 3 marks question. And you will say, not bad at all. But you can see here, all the angle properties that we know are now integrated back into the topic of bearings as well. And this is why we say mathematics is a spiral curriculum. The topics are connected. So I always say you cannot sit in a lesson and say, oh, I don't like this topic, so I'm just going to wait it out and then I will go back into the new topic. No, because the skills that we teach you in one topic will be a prerequisite skill for another topic. So what you need to do is to engage more with your teacher and say, I'm finding this content a little bit difficult. Can you help me? Because you are going to have a lot of conceptual gaps that will pose a problem when you get onto more complex problems. Okay, now we're going to move on to another question here. This time a 4 marker. So you're progressing. I'm so proud of you. So the diagram shows 2 points A and B. We're asked to work out the bearing of B from A. So I'm going to go to A. I'm going to draw my north line here, reference point, and I'm going to go to B from there. But let's just put a broken line here just to complete this triangle here so that we can see the connection between A and B. So I want to find all of this angle here. So from A, I'm going to B. So I can see here, I'm going to need to do the angle in the triangle. I can see here, I already know this angle here. These two lines are perpendicular, hence we know that angle there is 90 degrees. However, to complete the journey from A to B, I need to get the angle in the triangle as well. How will you do that? I hope you made the connection with the last lesson we did with regarding to our trigonomic ratios, because now this is an application question, hence a 4 marker. I'm going to need to apply my concept of finding an unknown angle from a right angle triangle, which takes me back into the concept of some old hippie came a hopping through our apartment, so katoa. Okay, so I'm going to label the angle within the triangle X. And now I'm going to focus on the sides of the triangle I have, and then choose the ratio, and then write the formula, and then substitute and calculate. You would have learned that from the previous lesson. Now, if you haven't done the trig ratios, I would suggest that you go back to the channel and you find that one on trigonometry, because the questions from this point forward will rely heavily on our trigonomic skills. So from X, remember, my reference point is always my angle. So I stand at X, and across from X is O. So I label that O. Now, across from the right angle is the hypotenuse. Clearly, there is nothing there. So the hypotenuse totally ruled out. So my other side is my adjacent. So I have labeled. Now I need to choose my ratio. So let's just write it here to visualize it. So Toa. So I need my ratio that has O and A. So it is the tan ratio, clearly. So let's go ahead. We chose our ratio. We're now going to write our formula down. So tan theta is equal to the opposite divided by the adjacent side. So I'm going to substitute now. X is my angle, which I'm trying to find, I don't know. So tan X is equal to, the opposite side is 55 millimeters, and the adjacent side is 40. And remember, we have to use our inverse function when we're finding an unknown angle. So therefore, X is going to be equal to tan inverse of 55 divided by 40. And in my last lesson, I've talked about how to bring up that inverse function on your calculator. So you'd simply need to press second function or shift on your calculator, depending on the one you have. You will see the inverse function coming up, and then you simply need to do 55 divided by 40. And that gives us 53.97 to 2 decimal places. So we put that on our diagram. So that's 53.97 degrees. Now I have enough information to go to my final answer. So I knew this angle here was 90 degrees, and I know this angle is 53.97. I just simply need to add them together. So my final answer will be 90 degrees plus 53.97. I'm just going to add 90 to my answer already in my calculator, and my final answer is 143.97 to 2 decimal places, and the degree of accuracy is degrees. Funny one there. So I hope you saw the logical sequencing of my thought as I thought through this 4 marker here. Brilliant. Okay, so now we're going to do some other questions involving SOHCAHTOA. Now, you will also be given worded problems. Never attempt a worded problem without diagrammatically visualizing it. And that's why at the beginning I taught you how to sketch a bearing. So you can sketch a bearing and then put your key points in on the diagram, closing your gaps. Another 4 marker here. Now the beach is on a bearing of 064 degrees from the airport A at a distance of 20 kilometers. How far east is the beach from the airport? Step by step we're going to do that. Remember, we always start at from. So the question here says from the airport. So that means my reference point is the airport. So I'm going to first of all start with a point, label it A for airport, draw my north line, put that in. Now the next part says at a distance of 20 kilometers. So I will use my ruler. I won't be able to draw this accurately, so just extend the line. Put your degrees in, so that's 64 degrees. So I'm estimating that. I'm using my concept in my mind of the cardinal points to the east, which is 90 degrees. So 64 is going to be somewhere along. Put that in and then put my point B. I will put my 20 kilometers there. Remember, we're not drawing accurately, it's just a sketch, so just extend your line. And now this is the part that makes me know trigonometry will be applied, because it says how far east. So you see, again, very important to know your cardinal points. So I know east bears to the right. So from A, I go along. I can see here an opportunity for a triangle. So I just simply close that bit in. Now I'm asked to find the distant east, which means that I just need to put my variable there. It doesn't matter what variable you use, but I give myself that focus as to which side of the diagram I'm asked to find. Now, if you notice here, in order for me to find this missing side, I need an angle within the triangle. So if you look here, we know that these two lines here will form a right angle. So it's easy for me to find the angle inside the triangle by simply subtracting 64 from 90. So if you want, you can call this one y. So y would be equal to 90 degrees take away 64 degrees. Just to make sure that I am dead on accurate here, I'll be using my calculators than I normally would, and it's 26 degrees. So I'm going to put that in on my diagram now. I have now closed my gap. I have all the information I need. So again, trigonometry. I am going to use my reference point as my angle. So I go to my angle here. I realize I do not have the opposite side completely ruled out. From my right angle, I know I have my hypotenuse facing that. And if the opposite is ruled out, then the x has to be the adjacent side. I then go along to think which ratio has A and H, and that's the cos ratio. So CAH, that's cos. So I've chosen my ratio. I know I'm doing cos. So cos theta, writing my formula, is equal to adjacent divided by the hypotenuse. And so then the angle is 26 degrees. So cos 26 is equal to my adjacent, which is the x, divided by my hypotenuse, which is 20. So therefore, remember from previous lesson, if my variable is in my numerator, I am multiplying. So x then would be equal to cos 26, which I need to put in bracket, multiplied by 20. Remember, we're not doing inverse functions now. We're just finding a side. Inverse function is only used to find an unknown angle, just to make sure that is explicitly clear. So I need to do cos 26, close my bracket, and then multiplied by 20. And the answer, therefore, for x is 17.975 if I write 3 decimal places out. Now, if you notice, this question didn't tell you the degree of accuracy. You are free to round to whatever, just clearly state that. So I'm just going to round this to 2 decimal places. So 1, 2, check. I need to round up. So it's 17.98 and the unit is kilometers. And just like that, you have now applied your trigonometric skills to your bearings question. Beautiful, beautiful. So we're now going to go on to another example. Now, a ship sails on a bearing of 120 degrees for 50 kilometers. How far east has it traveled? And again, I start off from my A because it says from. So therefore, I need to make my north line. I'm now going to draw 120 degree based on estimate again. Put that in on my diagram. And then I need to write my 50. And it asks me how far east. So I need to go along east and then close my diagram here. Now, if all the angle from here is 120 degrees and this bit here is a right angle which is 90 degrees, it tells me then that this angle here has to be 30 degrees because 90 degrees plus 30 degrees gives me 120 degrees. Now I have the information in my diagram. So I've put the SOHCAHTOA ratios here so that you can help to navigate that. I should have done that on the previous question, but I ran ahead of myself, but now you've got it here. So the side I'm asked to find is this side, east. So I put that in on the diagram. Now, remember, I'm going to stand at my angle and I'm going to label my diagram. I can see again, I do not have the opposite side, so that's ruled out. This is my right angle here, so this is my hypotenuse, and this here is my adjacent side. So therefore, I have A and H again. So I'm using the cos ratio. So I'm just going to put a little tick under that. So let's write cos X is equal to the adjacent side divided by the hypotenuse. In this question, the angle is 30, so cos 30 degrees is equal to my adjacent, which is X, divided by my hypotenuse, which is 50. Again, the variable is on the numerator, so I am multiplying. So X is equal to cos 30, which I put in bracket, multiplied by 50. So we put that in our calculator. So cos 30, close my bracket, and I'm multiplying by 50, and I have 43.30. So this one I'll just keep to 1 decimal place, so it's 43.3 kilometers. Brilliant. Everything's just coming together so smoothly, so beautifully. And, you know, make sure that you are practicing. Remember, practice make things permanent. Okay, we go to another question. Now, I have put here angles of elevation and depression because I want to ensure that it doesn't matter the language that the exam speaks, you know exactly what you're doing. So an angle of elevation is created when we are looking at something above our line of sight. Your line of sight is what you look straight ahead and see. So if you can imagine a straight line being created with your eyes and the object you're looking on, once you have moved away from that line of sight and you're now looking at something above, you have created an angle of elevation between your line of sight and the object above that you're looking on. The reverse is also true. This is my line of sight. So if I'm looking down on something, the line of sight I've got looking straight ahead will create an angle with the object I'm looking down, and that is called the angle of depression. Yes, angles can get depressed as well, apparently. Okay, just to put a little funny one there. Okay, so we're going to do this question. John is standing on a cliff looking down on a boat. how high is John from the level of the boat? Now, importantly here, you do not always get the visuals here. But if you do not get the visuals, sketch the diagram. So basically, we're asked to close this triangle to find the height here. So again, I'm going to be using my trig ratios. I'm going to go, let's just call this bit here the height, h. So from 26, this side will be the opposite. And here will be the adjacent side because the longest side faces the right angle, and that's not labeled here. So I've got OA, so I'm using clearly the tan ratio. So tan theta, write our formula, is equal to our opposite side divided by the adjacent. Now we're going to substitute and calculate. So tan 26, that's the angle given here, is equal to the opposite, which I've labeled the height, since that's what we were asked to say, how high, and that's divided by the adjacent, which is 450 degrees. So again, my variable is in my numerator. I'm going to then multiply. So h then will be equal to tan 26 degrees, which I put in bracket, multiplied by 450. So we get our calculator. It is tan 26, close my bracket, multiplied by 450 degrees, which gives me 219.479, and I'm going to just round that to one decimal place. So the height then is 219 points. I've got a 4 here, 7 follows after. I'm rounding up, and the unit is meters. Another brilliant execution in a clear logical sequence there. Beautiful. Now we move along. So here, still on angles of elevation and depression. So Bob is at the top of a vertical cliff that is 80 meters high. He sees a boat out at sea. The angle of depression from Bob to the boat is 34 degrees. How far from the base of the cliff is the boat? So visualizing that, I put my 80 in for my height there. And I visualize my boat as well. So now, across from there would have been his line of sight. Now he has an angle of depression looking down, so that's the angle there. Now you can see here, we can also close the triangle here by putting this line in. Now because we know that the opposite sides in a rectangle are identical, it simply reasons that the side here is also 80 meters. And now we're asked to find how far from the base. Now here across would be what we're asked to find. However, it's also identical to the side at the top. So therefore, we can just find that side because it's also on the triangle. So now we have enough information. I've got an angle, a side, and the side I want to find. Great. So again, I visualize. I go to my reference point, which is my angle. So this side here is my opposite side. Label that O. And this side is my adjacent side. Brilliant. So I go in OA. I'm also using the tan ratio. So tan theta is equal to the opposite side divided by the adjacent side. So the angle is 34. So tan 34 is equal to the opposite, which is 80 meters, divided by x. Now I can see that my variable is in the denominator, which means I will have to divide. So x then will be equal to 80 divided by tan 34. I simply need to put that in my calculator. So here we go. So 80 divided by tan 34, close my bracket, press equal. The answer then, x is equal to 118.6 to 1 decimal place, and the unit is meters. And there we have it. We have completed a question both on the angle of elevation and one on the angle of depression. Beautiful. I want you to just pause, just take some time just to digest this beautiful thought here. And then never be afraid of doing trigonometry again, because I've proven that this topic can be beautiful, it can be smooth once you have that little detail explanation. Brilliant. Now, we have come to a very critical part in your learning process. What are you taking away from this lesson? Now, the first thing we looked at was that in mathematics, when we talk about a bearing, we're talking about an angle measured clockwise from the north. We looked at some key facts of bearings, and at this point you should pause and just ask yourself some things. What are some things I learned? Write them down on a paper and then play the video again and see, did I really capture all the essence of this beautiful topic? So we looked at the fact that bearings are measured direction taken from the north. We also talked about the fact that it always has to be in a clockwise direction. We talked about the fact that we must represent these bearings with 3 figures. And we've also looked that we always start with a point that comes after the word from. Beautiful. Beautiful. I hope that you've managed to capture this positive energy I'm throwing out there, because I feel so, when I talk about mathematics, I am so excited, and you can tell. So before I go, let's just talk about a few little things here. Something that means so much to me. Now, when I started this channel, my intention was to inspire students to appreciate mathematics, that it is not just a subject, but rather it is a set of life principles by which we live. Everything we do in our life takes in some mathematical knowledge, or even without you knowing it, you are doing some mathematics. Now, the fact that you have engaged with this channel means to me that you are really interested in your education, one, and also the fact that you've taken the time to subscribe. It really encourages me to carry on with what I'm doing, because it tells me that someone out there is really enjoying, and making a deep connection with what I'm trying to do to help students to progress, not just in their classroom, but also in your exams. And so I want to tell you, every single one of you that have connected and engaged with this channel, I deeply appreciate you. Thank you so much. And thank you so much for watching this lesson today.